Let us read this problem fast and then we'll discuss. Let us say we will approach this problem from graph. So let us say fast drive velocity time graph, and on the y-axis we will plot velocity. So this is on the y-axis we will plot velocity. On the x-axis we will plot time. So this is a velocity time graph. If you remember, velocity time graph, slope of velocity time graph is acceleration. Are you getting or not? So slope will give you the acceleration. Velocity time graph, slope, acceleration. Are you getting or not? So initially question says initial velocity is 0 and it will start with acceleration w. So here you have initial velocity, that is 0, and it starts with acceleration w. It goes with acceleration w for some time. Let us say it move for a time of t naught. So this is moving for a time of t naught. So this time interval from 0 to t naught. So this time interval you have t naught. For this time this is accelerating, so this is a acceleration case, and that's why we have shown this slope is positive. So this is a positive slope, acceleration. Now after this time, then it moves uniformly, that is the constant velocity. Now this car is moving with a constant velocity, so this time it is moving with a constant velocity, and then again it starts a deceleration, and it's a start deceleration, finally it comes to rest. And it is given in the question that deceleration is always w. So rate of deceleration, that is deceleration, is always w. So this means this time is again t naught. So this time interval should be t naught. You can understand this one clearly. You have increased the velocity with acceleration w and you are getting some velocity here. What is the velocity here? So you can find formula v is equals to u plus at. So if you apply v is equals to u plus at, and this initially u is 0 plus, and this acceleration is w and time interval is t naught. So this is w t naught. So velocity at this point is basically w t naught. So this point, this velocity is basically w t naught, and this is moving with a uniform velocity w t naught. So here also you have velocity w t naught. Final velocity is 0. So you can prove this time interval is t naught. You can prove easily. Let us prove this one. Final velocity is 0. Apply v is equals to u plus at again, and then you can prove v is equals to 0. And acceleration, you have basically deceleration. Initial velocity here you have, that is omega into t naught. Are you getting or not? So at this point you have velocity omega into t naught, w into t naught, whatever you want to say, w or omega. This is w into t naught, and acceleration basically you have deceleration, and this is w, and let us say this time interval is t. So from here you can prove this time t is equals to t naught. Are you getting or not? So this is time t naught, and the question also says total journey requires a time tau. So this means this time interval is basically tau minus 2t naught. I think all of you are able to understand this one. Now we have to find now average velocity. So what we will find is, let us call this point as a O, this is A, this is B, this is C. So distance between 0 to t naught time. So total distance we want to calculate, so we can basically calculate total distance. Total distance, or in this case motion is in one direction, so this becomes displacement also. So total distance is, in this journey we can apply s is equals to ut plus half at square. So u is 0 plus half omega is w, is basically acceleration, and time is t naught, so half at square. So this is the displacement in this journey. What is the displacement in this journey? Now s is equals to ut plus half at square. Now ut, that is initial velocity, is omega t naught, and time in this journey is tau minus 2 t naught. So this is the displacement in this journey. And what is this displacement in this journey? Again, we can apply s is equals to ut plus half a t square. So initial velocity we have, that is omega t naught. So omega t naught ut, and time is basically t naught. So omega t naught, and acceleration is negative, so minus half omega, and time is t naught, so half t square. So this is the total displacement, you can say. So this is half omega t naught square, and this is plus omega t naught and tau minus 2 t naught, and this is minus, so this is plus half omega t naught square. Now this and this becomes 1, so this is basically omega t naught square plus omega t naught and tau minus 2 t naught. Are you getting or not? And this total time is tau, so average velocity we can find, average velocity, that is average velocity. So we will have average velocity. So average velocity is omega t naught square plus omega t naught tau minus 2 t naught, and this divided by tau, because total time tau is given. Now we can put the numerical values. Average velocity is 72 km per hour, so this is 72, and we can basically convert into meter per second. So kilometer is 1000 per hour, that is 36, 60 into 60. So we can convert into 1 hour has 60 minutes, and 60 minute has 1 minute has 60 seconds, so we have to divide by 3600. And acceleration omega is also given to you, that is a 5, and tau is 25. So this is omega is 5 and t naught square 5 t naught, and tau is 25 minus 2 t naught, and this is again 25. So we can solve this one. This 20 goes, and 36 2, so we have 20. So this side 20 into 25, this is equals to 5 t naught square plus 5 t naught, 25 minus 2 t naught. So if you cancel 5 also, so you will have 5, and this becomes 100. 100 is equals to t naught square plus t naught, 25 minus 2 t naught. Now let us say you can multiply this one, t naught square plus 25 t naught, and this is minus 2 t naught a square. So this is minus t naught square, this comes this side, so becomes t naught square plus, and this is minus 25 t naught, and this is plus 100, this is equals to 0. Are you getting or not? We have to solve for basically t naught. So we can factorize this one. So t naught square minus 20 t naught minus 5 t naught plus 100, this is equals to 0. And if I take t naught common here, we'll have t naught minus 20, and if I take minus 5 common, we will have t naught minus 20, this is equals to 0. Now if I take t naught minus 20 and t naught minus 5, this is equals to 0. This means t naught is equals to 20 second, or we can have t naught is equals to 5 second. Now among these two, one will be physically have meaning and one physically have no meaning. Basically we have to find this time interval, that is tau minus 2 t naught. So let us find tau minus 2 t naught. So if I take t is equals to t naught is equals to 20 second, that is 25 minus 2 into 20, so this will have a negative value, so physically it has no meaning. So this means t naught I have to take 5 seconds, so this is equals to 25 minus 2 into 5, so that is 10. So this is basically minus, so this is minus 2 into 5, and that is 10. So basically we will have 15 seconds. So this means the car is moving with a constant velocity for 15 seconds. So car is moving uniformly for 15 seconds. Are you getting? So this is the idea. This is easy one. You see what we have done, we have used only one concept, that is idea of average velocity. So if you see, the whole problem involves only one concept, that is concept of average velocity. Are you getting or not? So we can apply s is equals to ut plus half it. For this kind of problem, graphical approach is a good idea. Are you getting or not?